It's related to the class. It's not completely random, useless information. You know how much I like that stuff, though. But it's something we're going to talk about later, and it's when I'm not going to be here. Remember, y'all voted to like have a video, right? It's related to exponential and logarithmic functions. So I came across this last night, this video, and on YouTube, and I thought it was really cool, so cool that I want to do it. You may not think this is cool at all, but what we're going to do is like an experiment, all right? That sound fun? No? Okay, so just take out a sheet of paper. It's not a quiz or anything. And this is going to take a little bit of time. I might actually go grab my laptop while we're doing this. But what I'm going to do is I'm going to pass around these two little buckets here, okay, these little plastic food containers. I'm going to pass these around. I don't need you to look at them. All I need you to do is put them in your hands and try and figure out which one's heavier. Okay? And it says A on top of one of them, and it says B on top of the other one. All right? So I just want you, don't open them up, or just like this. Okay? Take a guess as to which one you think is heavier. Understand? And then write down either A or B on your sheet of paper, and then pass it to the next student. And everyone's going to do this. And then we're going to collect all that data. All right? Okay, so while this is happening, I think this is a good time. I'll run down to my office. All right? Everyone understand what we're doing? In the meantime, if you want to look over your exam, you can. And I'll be back. Hopefully you'll be done. Don't share. There's no like, if you get it wrong, you get it wrong. Okay? You're not going to be penalized. So don't be sharing each other's answers. I want you to make your own opinion on that. I'll be right back. Where is it at? Oh, we're still going? So you wrote down which one you thought was heavier, right? Okay. Has it gone here yet? Okay. Okay, thank you. Now I brought this little scale here. This is I think it's a food scale, but all right, so what I'm gonna do is I'm gonna weigh these in grams. Everyone got their pick? Don't change it, okay? Okay, the first A weighs 75 grams. And B, is it going to weigh more or less for B? B is 48 grams. Okay, so show of hands here and keep your hands up. How many of you thought that A was the heaviest? Wow, 100%, right? Everybody got that. Good job. Okay. I'm gonna add some batteries to these. Okay, do it again. While y'all are doing that, I'm going to post the grade information up here. So same thing, different experiment, which one weighs more? Take your time too if you really need to. Where the heck is it? Okay, so while that's going around, these are the grades for test 1. We had 10 A's, 6 B's, 1 C, 2 D's, 3 F's. We had a class average of 83.17, and this number right here, 15.7, gives you an idea of how far apart the grades are. Now, here's another way to look at it. If we had 2 students in the class, all right, let's just say there were only 2 students, and we had their scores on the first exam were 0 and 100, what would the average be for the class? 50, right? You add this up, you divide by 2, you get a 50. So the average here would be 50%. Okay, so what if they took the test and it would have been 25 and 75? What would the average have been? Still 50, right? And what if they both got 50s? Then what would the average be? Still be 50, right? So the average does tell you something about how the class is doing. But this number right here is called the standard deviation. We use this in statistics. And what it does is it tells you how far apart the grades are spread. So if you look back at these scenarios here, this if this happened, we would have a very large standard deviation. It would be a very large number. It would tell me that those grades are really spread out, okay? This would be a smaller standard deviation, and this would be a standard deviation of 0. Make sense? So we have a standard deviation in this class of 15.7. That is, it may look big. That may look like a big standard deviation. That's about what I get in almost every class. No matter if it's calculus or college algebra, I usually get a standard deviation anywhere 13 to 16. When it goes past like 18 up to 20, that's when I get real worried, because it means that I have students who get it and students who don't, and so I'm okay with this. We done? Yeah. Who else? Anyone? Okay. Sorry. No, it's all right. All right, so we'll go here. This chart shows the actual grades. Tests are up on that table. Anyone else need to get their test? So these are the actual grades. This is the passing line. So you can see the highest score on the test was a 105. That was the most points you could possibly get. And then lowest was 45. These are the students that might want to talk to me after class. But again, it is only the first exam. All right. So, but please talk to me after class if you have any questions or concerns about your grade. All right. Questions or comments on this? The way I graded the exam, just so you know, if you're trying to figure out how I came up with that grade, I always grade every test treating each problem as if it's worth 10 points. All right. So like if you miss 5 points on a problem, that means I think you halfway demonstrated what you were doing, all right? There were 23 problems, but I counted 23 as a bonus, all right? So if you got the bonus right, it'll say like +5 or +4 or something like that. So that means that there were only 22 problems actually graded on the test, and if they're each worth 10 points, that means there's 220 points possible, right? 22 times 10. So what you can do is you can go in, you can see if I took off like -3 and then -5, you can tally all these up, right? And you can figure out, let's say it was -40 total. Then you just subtract 40 from this. That would be 180, okay? And then divide that by 220, and that'll give you your decimal grade. You convert it to a percent, you move the decimal place 2 places, okay? Make sense? But there was one problem on that, and that's number 15 and number 16. Do you remember I told you last class that I was grading it, but I didn't get through the whole test? Well, I had stopped at number 14, and then when I went home, I actually picked up on number 17. So I didn't grade 15 and 16 until I went to go put the grades in. That makes sense. So I went to go tally up all the grades, and I realized I didn't grade anyone's 15 and 16. So I graded those mentally, okay? So I took off points if I felt like if something was wrong. So what I'm getting at is if you do this adding up all your numbers and you do this whole thing and it's off, it's because something is off on number 15 and 16. All right. I do plan on putting a key out there so you can go back and you can look at what went wrong. But again, if you have any questions over your grade, just talk to me after class or before class, and I'm usually down in my office, and we'll get things squared away. Okay? Sorry to confuse you. Let's talk about the experiment. That's it for my computer. All right, so we had, on the previous one, it was A was 75 grams, and then B was what, 48 grams. And we had 100%, right? So let's see, 1, 2, 3, 4, 5, 6, you weren't here, 7, 8, 9, 10, 16, 17. We had 18. 18, get this, say it was this one, and 0 said this one, right? Okay, so then we ran the experiment again. We have A and B. Let me go ahead and weigh those. So where are they? Right here. Okay. Now we're going to have to throw your vote out because you weren't here for the first one. All right. All right. Here we go. You ready? You nervous? You shouldn't be. Okay. 345 grams for A. What do you think? What do you think? More or less on this one? On B, what do you think? Okay, 318. Okay, now it's, again, I need to know your truthful answer, okay? How many of you said A was the heaviest one? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, and that means we had 8 that picked that one, right? What the heck does this have to do with math at all, right? I mean, I guess it's an experiment, but this actually has to do with something called Weber's law. All right, I believe it was like the 17 or 1800s, this guy named, last name Weber, started to realize this sort of thing. So I'm going to do one more small experiment. To try and illustrate what's going on here. Get all the lights on. All right. Okay. How many of you noticed I turned my flashlight on? Okay. I mean, you saw me do it, right? But otherwise, if I had just done that, would you have known I turned my flashlight on? See, it's on right now. It's off. It's on. It's off. Okay, right? Is it easier to tell? Okay. I know that may seem ridiculous and stupid, okay? But just bear with me for a second, all right? So here's the way, this is where the mathematics and the logarithm comes into play. All right, so let's talk about this weight thing. All right, I'm going to make a graph. And this is going to be the weight. Did I spell that right? I thought it's not I before E, except after. See, perfect example. All right, weight. And then this is going to be your feel or your response. Okay, so when the weight was 48 grams, right? If I change that weight to 75 grams, which let's say is right here, that's a change of what, by about what, 27 grams? Change it by about 27 grams, right? And your response, you could feel it, right? I mean, you could really tell that there was a difference between those two. With that small change in weight, there was a big feel or a big response. Does that make sense? So if I say, let's say, this was your feel, and we were very accurate, what we could imagine is like 2 points here. We could say that with a small change in weight, we had a big response, like a good ability to be able to perceive the difference. Now, if I go out to 318 grams, which is out here, way out here, right? And then I changed it by, well, it should be the same, but let's see, that scale might be a little off. What's the difference between, it's 27 again, right? So if I change it by 27 again, I still have the same change, right? The same difference here. But what about the difference up here, your feel? It was obviously, what, 10 and 8? There was less of a correctness, I guess, in that feel. Your feel for it kind of diminished. So that means I would have a point here and then maybe a point slightly above it, so you'd have a small change, right? Does that kind of make sense? Small change here, big change here. And what this gives us, if we were to kind of connect these, I'll have to redo that, okay, is a graph that looks like this. And it actually would come down like that, okay? And this is not a line. This is not a linear function. It's not a linear equation. It's not a parabola. It's not any sort of polynomial. It's a very special kind of function called a logarithm, all right? So we will study this later on, but I just wanted to kind of give you an example of something that you could actually do that would show you like where a logarithm could come into play. Let's change this to the light instead, right? When the lights were on, that means the lights, this would be like brightness in the room. When the lights were very bright, right here, and I turned on, I added a little more light to it, right, with my light, there was a very small response. You couldn't really tell that I had added light into the room. However, when the lights were off and I added a little bit of light, and then you could tell, right? One last example. How many of you remember when you were a little kid, a year seemed like a long time, right? And as you get older, right, so when you're a kid, you know, you have your birthdays and whatever, and years seem to be long periods of time, right? That's your impression of what a year is. But as you get older, right, all of a sudden they start rolling by, right? You ask someone who's like in their 70s and they're like, you know, life goes by in a blink of the eye. That's because as you get older, your perception of time starts to diminish also. So it's kind of interesting. There's a lot of things in the real world that kind of behave like this. And so, you know, we could talk all day about logarithms, but the whole point is that what we try and do in mathematics is we try and look at the real world, we observe things, and we try and find mathematical functions or equations that somehow represent what's going on. And that way we can predict. We can try and figure out what, you know, predict what's going to happen later or something like that. So anyway, it's not a line, so we need something else. Logarithms will be what we need, and we'll study those later. Okay? All right, but today we get back to factoring and solving specifically quadratic equations. So any questions on the homework? Any questions on the homework? Let's see, what's that? No? Okay, well, if there are no questions, then we will proceed. So if basically what we went over last time is factoring, and that we had this like set up like a procedure to factor, right? We did GCF, and then what was after GCF? I forgot. What was it? I didn't forget. Yeah, but yeah, you're going to count the terms, right? So after you do a GCF, if there is a GCF, you then count the terms. If there's 2, you do one thing. If there's 3, you do something else. If there's 4, you do something else, right? Okay, so hopefully you got some practice with that on the homework. Now today, we actually go about solving equations, all right? So solving, I'm going to say nonlinear equations with factoring. So I talked about this last class. I actually tried to motivate the whole idea of why we factor with the idea that we're going to use it to solve equations. So now we get to do that. Nonlinear, why do you think I'm saying nonlinear here? What do you think is important about me saying that? Like if I were to tell you how we solve linear equations, would I be talking about the same thing? Would I do something else? I do something else, right? So if it's nonlinear, then we can use factoring as a tool to try and solve some equations. So let's start out with the first one. Let's go. So how about 9x squared minus 16 equals 0? Now that is an equation, right? And it's actually, last class, you would not have had equals 0. You just would have had that right there. And I would have asked you to factor that, right? But now I'm adding the equal 0 into it, which means we should have a solution or multiple solutions. But we're going to use factoring to do this. So that means we are going to look on the left-hand side and see if we can factor that. So look first for a GCF. Do we have one? Is there a greatest common factor out of those? A number that goes into both 9 and 16? No? And then there's not x's in each one, right? So there's no GCF. All right, count your terms. We have 2 terms, right? If there's 2 terms, it's got to be one of those special things. It's either got to be a difference of squares, sum of cubes, or difference of cubes. Is this one of those? Yes. Yes, what is it? Difference of squares, right? So that means it's going to break down to be 2 sets of parentheses. And what goes in those? 3x plus 4 and 3x minus 4, right? So I'm trusting that you have done your homework. You kind of understand what we did last class. 3x plus 4, 3x minus 4. And again, referring back to what we did last class, I had shown you that zero factor property that said if a times b equals 0, then either a equals 0 or b equals 0. So that was where we got the idea that from here, if 2 things multiply to be 0, that we're going to set each of them equal to 0. So I set 3x plus 4 equal to 0. And then the other equation I need to solve is 3x minus 4 equals 0. Both of those are linear equations. So all I have to do is solve them for x. So I'm going to just move the 4 over and then divide by 3. Here I'll have to move the 4 over and divide by 3. I'm going to get 2 different answers here. The first answer, what's that going to be? Negative 4 over 3, right? Because when you move that over, it becomes negative, and then you divide by positive 3, you get this. On this one, when you move the 4 over, it becomes positive, and then you divide by 3, you'll get positive 4/3. So these are your 2 solutions. And that just means that if you take 4/3 and you plug it in right here and square it, then multiply it by 9, subtract 16, you should get 0. We won't check it, but that's what this is saying. And then also, if we plug in negative 4/3, square it, multiply by 9, subtract 16, we should also get 0. Yes? Do you have to use factors? You do not. There's some other techniques, but we're going to do those today, but just not yet. All right? This is solving equations with factoring. We will have solving equations with something else in, well, I don't know, 30 minutes, 40 minutes from now. All right, let's do another one. How about this one? 2x squared plus 5 equals 2x minus 7. I think I'm going to turn the light back on. It seems kind of sleepy in here right now. All right, so first thing, is this a linear equation? Is it linear? No? Why not? Because it has x squared, right? So we are looking at a linear equation, nonlinear equation, and let's try and do it by factoring. So I didn't mention this in the previous problem because it already looked the way we need it to look. Notice how it was equal to 0, and then we did factoring. We must do the same thing with this one. We must get it equal to 0 first. All right? So that means we need to choose either to move these 2 guys over to this side or move these 2 guys over to this side. I'm going to choose to move these 2 over here. So that means I'm going to subtract 2 on both sides, and I'm going to add 7x on both sides. So subtract 2 from the 5, and then if I'm adding 7x, I can't add it to this because this is x squared and that's 7x. They're not like terms, so I can't put them together. So what would my left side look like then? 2x squared plus 7x plus 3, right? So we also put it in descending order, the highest power of x down. So I had 2x squared there. I added the 7x. 5 minus 2 is 3. Then equals the right-hand side, which should be 0. Questions there? Sure? Okay, now same game. Just kind of ignore that for now and just do your factoring right here. So this one, do we have a GCF? No greatest common factor. Count the terms, there's 3. And because there's 3, we're going to use like that AC method or the guess and check, whatever works for your brain, right? So I'll do the AC method over here. What do I put up here? 6, and then down here, 7. So we're trying to find two numbers that multiply to be 6 and add up to be 7. So what? 6 and 1? And then you would go through the whole grouping thing now, right? Now, let's try and save ourselves some time. I'm not actually showing this step, okay? There's like some dots here, meaning you would have to maybe do a little work like we did last class. Let's see. What does it turn out to be here? I think yeah. So please understand, from here to here is some work, right? Now we have something times something equals 0, so we set them each equal to 0, and we're on our way, right? And it's the thing about, one of the things about math that makes math challenging for a lot of students is how it does build on itself. You know, I mean, we have to be comfortable with this factoring now in order to do a problem like this, right? If you're still struggling on this factoring, then this problem becomes very difficult to do. And then later on, as you move on, then you have to be able to solve equations without any problems, or else you can't do the other math. And it's like a pyramid. You know, if you don't have a good base, then you can't build the pyramid. So I understand that there are inherent problems in mathematics. It's just the nature of the beast. All right, so here we're going to move the 1 over, become negative, and then divide by 2. Here, all we have to do is move the 3 over, so it becomes minus 3. So I'm showing less steps, right? Do y'all notice that? I'm not showing as much work, and that's just because, I mean, you may need to, and that's fine, but because of time and because we have to progress, we have to show less work as we proceed. All right, comfortable with that? Okay. How about this one? So this is nonlinear, right? Any ideas on what to do here? Set it equal to 0 first. What do y'all think? Get it equal to 0? Okay. I totally agree with that. But I want to point something out, a mistake that students sometimes make. All right? Sometimes students will do this. They'll divide both sides by 4x. And let's just say I did that, all right? What would this be over here if I divided by 4x? 4 divided by 4 would be 1, right? X squared divided by x would just give you x. Then the right side would be what? 2. Now, is that answer correct? Let's just check it real quick. If I put 2 here, what's 2 squared? 4. 4 times 4? 16, right? 8 times 2? 16. So it's correct, right? We got the correct answer? But is it the only answer? What other number could I plug in here and here that would have worked? 0. And see, you didn't get that answer if you did it this way. Do you see that? You kind of like missed the solution. And that's why you never want to divide both sides of an equation by a variable. You can, like if you want to divide by 4, just 4, I have no problem with that. But never divide by 4x, because that x being in the denominator eliminated one of your answers. So if you want to completely avoid that and never have that problem, then we set it equal to 0 first, like I had said. So that means I'm going to move this 8x to the left side, which makes it negative. And now, GCF, 4x. I can pull a 4x out. I'll be left with x minus 2 equals 0. Yes? Now we can use the zero factor property again. This is multiplication right here. And so what I'm going to do is I'm going to set 4x to 0. I'm going to set x minus 2 equal to 0. I think this one's the easier one. Just move the 2 over, you get 2. We already knew that that answer was good, right? But now we're also going to get the other answer. And so 4 times what number is 0? Well, there's only one number that would work, right? And that's 0. So x is 0. There we go. So that we got our two solutions. So the moral to the story here is just if you have a nonlinear equation, try and move everything to one side. Don't try and do any crazy other stuff first because you can get yourself into trouble. Y'all look thrilled today, just absolutely thrilled. All right, since I seem to be boring some of you, so let me try this one. Okay, is this a linear equation, nonlinear? Nonlinear. Every problem I'm going to give you is going to be nonlinear, but it's something we want to always be thinking about because if you take a test, you need to be able to identify if it's linear or nonlinear because that changes your strategy, right? The way you attack it. So this is going to be quadratic, nonlinear, and you hate fractions. So what's your plan? You want to multiply what? So you're looking at, you said 10? 20. Okay, I'm sorry, I thought I heard 10. So there is a way when you have an equation for you to clear out the fractions. And we did this with linear equations. I think I did 1 or 2 examples where we cleared the fractions out. And I'm going to do the exact same thing here. I'm going to look at the denominators, 5, 4, and 10. And I'm going to try and find the least common multiple of these. So you just list out their multiples, 5, 10, 15, 20, 25, keep going. 4, 8, 12, 16, 20, 24, ... Next one, 20, 30, 40. And you're looking for the smallest one that they all have in common, which is 20, right? So you find your LCD, least common denominator, and you multiply both sides of the equation by that number. So I'm going to take this entire left side and multiply it by 20. I'm going to write it as 20 over 1. And I'm going to take this side and multiply it by 20 over 1. Why did I put parentheses here and not parentheses over here? Because I have to distribute. The 20 has to go to both of these, right? If this only had one term, then I don't need parentheses. So when I multiply here times here, the 20 times the x squared gives me 20x squared. The 1 times the 5 gives me 5. Plus, when I go here to here, 20 times x gives me 20x over 1 times 4, which is just 4. And then what about the right side? This is 60 over 10, right? 60 over 10, which is just 6. Now, it may look like you still have fractions, but these fractions reduce, right? What's 20 divided by 5? 4, so that's 4x squared, plus 20 divided by 4. It's 5, so 5x's equals 6. Now, doesn't this look a little bit more like the problem we did, well, not this one, but the one before that? We've eliminated the fractions, and we have a nice nonlinear equation there. We're going to move everything over to one side, and then we'll start with our factoring. Questions? You sure? Y'all are still quiet today. I thought that experiment would get you all happy and no? It is kind of lame, but oh well. So here I just moved the 6 over, right? Became negative 6. And now you get to do your, what, GCF we don't have. Count the terms, 3. AC method. Negative 24 and 5. What works? 8 and negative 3? I think for this one, I'll actually show the work. I'll just go fast. I'm going to rewrite 5x as 8x minus 3x. So I rewrote this using these two pieces right here, which came from those two numbers. Then I slashed it. I'm pulling a 4x out of the first one, which leaves me with x plus 2. What do I pull out of the second two? Negative 3, which leaves me with x plus 2 again. Now notice, I forgot equals 0 here, equals 0. And now, because these two things match, this becomes x plus 2 times 4x minus 3. So there's your factoring. And now we just set each of these equal to 0, and we're there. Now I'm not even going to show me setting those equal to 0. I'm just going to write the answers. If you set that to 0 and move the 2 over, you get this. If you set that to 0 and move the 3 over and divide by 4, you get 3/4. So you'll want to make sure that you can get from here to here on your own. All right, so that problem was a little more involved. We had to clear out some fractions first. After that, little AC method, and then we were back in business there. All right. So this is the first time we've had this appear, right? Cubed. It's nonlinear though, right? So we're going to try the same method. Let's try and get everything over to one side first. So I'm going to move that 90x over. It's going to become negative 90x. And I also made sure that I put it in descending order. And now I try and factor. So first step for that is what? GCF. We do have a common factor here this time, don't we? What is it? 10x, right? These are all multiples of 10. So 10x. Okay, let's see. 10x. What would that leave you with in here?
8x squared minus 6x minus 9.
Just remember to be bringing down that equals 0, right? Because we have an equation this time. Now, you can double check to make sure you got the right GCF by just looking at these numbers again and making sure there's not a number that goes into these. So like 8 and 6 is 2, right? But then 9, 2 doesn't go into 9. So sometimes you pull out a GCF and the number you pull out is not quite big enough. And so like you might have to pull another number out just to make sure you've got it, you know, all the way, the greatest common factor is pulled out. All right, so we've got that out. We've got multiplication here, which means we will set that to 0, but we need to deal with this first. So this right here, 1, 2, 3 terms, and AC again. So what? Negative 72 here, and negative 6. Now, in last class, at the end of last class, you were doing some problems like in groups and stuff. I did not put those grades in, by the way, the quiz grade there. I will do that. But a lot of you were having trouble with this part, the coming up with the numbers and just kind of working. And that's just going to take some time for you to get used to that. But I'm going to have to trust that you can get these two numbers if they exist. So do they exist here? Negative 12 and positive 6. Okay? So once you have that, you can start breaking this down, can't you? Now I think because this might start to look a little ugly, I think I'm going to do the breakdown over here. So I'm leaving this here, and I'm going to do what would be considered scratch work on the side, okay? This is kind of like some work that I'm going to be doing in order to get that answer. So I'm going to take my 8x squared minus 6x minus 9, just kind of treat it like its own little problem over here. I'm going to rewrite it as 8x squared, rewrite the minus 6 using these two numbers. So minus 12x plus 6x minus 9, and then I'm going to start to group. So what can I pull from that first one there? 4x, and you're left with, let's see, what's left in here? 2x minus 3. And then I need to pull something out of here. 3, I can pull a plus 3 out. And that leaves me with 2x minus 3 again. And since they match, then you can rewrite this. You're going to have 2x minus 3 and then these two pieces. So I'll go ahead and come back to this now. I had the 10x out here, but now this thing has two parentheses and then equals 0. So it was 2x minus 3 and 4x plus 3. You all with me? I feel like I'm moving too fast for some of you and then too slow for some of you, so trying to find the middle ground here. Set each of these to 0. And then solve each of those little linear equations. So what's the answer for the first one there? 0, right? 10 times what is 0? Well, x must be 0. All right, and then this one, x is 3 over 2. And then this one is x is negative 3 over 4. So the solutions to this equation, you can plug 0 in here, and it should give you, 0 equals 0. You can plug 3 halves in here, here, and here, and they should be equal. And then you can plug negative 3/4 in here, here, and here, and it should be equal. All right? Notice that we had a 3 here, and we got 3 answers. And when we've had a 2 up here, like the previous problem, when we've had 2's up there, we've been getting 2 answers, right? There's actually a property that says that whatever the highest power is, that's the most number of answers you can have. Okay, it's the most. You can actually have a 3 up here and have 1 answer. You could have a 3 up here and you could have 2 answers. You could have a 3 up there and have 3, but it's impossible to have a 3 up there and have 4. All right? It's tied into what's called the fundamental theorem of algebra. But it gets a little complicated because you have to also you also have to count imaginary numbers in that. For example, x squared plus 4 equals 0. If you look at this right here, this is an impossible equation to solve because you can't square something, yeah, or square, I haven't done that yet, but think about, if I square a number, it's got to be positive, right? At the worst that could happen is I plug 0 in here. 0 squared is still 0. So this right here, the worst it could be is 0, but otherwise it would have to be positive, right? If I add 4 to it, it would be impossible to get 0. This has to be negative, right? It has to be negative 4 in order for this to work. So you might argue that there's no solutions here, but there are actually 2 imaginary number solutions. But we're not talking about imaginary numbers in here, unfortunately. Well, in the 1414 class, we have to deal with imaginary numbers, but not here. I mean, we'll deal with them, but not in any meaningful way. Okay, you ready? Let's do one. You do one. Take it from the beginning to the end. So do 30x cubed minus 2x squared. Well, let's make that equals 2x squared plus 4x. All right, take a few minutes, see how this goes. I'm missing something. Oops. 5x. Let's see. I'm going to be pulling out. Keep working. I'll give you a few more minutes. If you got to the answer, great. Just hang tight. Let's go like another 30 seconds. Okay. How'd y'all feel about that? Think you could do that on your own? Okay. So I worked it out up here. Any questions over this? Is anyone trying to do this a different way? I'm not, again, I've told you that like if you have a way of doing things, I'm okay. I'm not here to like reteach something that you know, but I just want to make sure that your method is okay. Like sometimes people use some weird things that aren't really safe. We're all right with this? I think maybe this part right here, just don't forget that if you have 5x plus 2, if you don't have a GCF, remember you have to pull something out. So I have to pull out a positive 1 here. All right, so that part's a little bit weird.
What happens if the number that the greatest common factor doesn't have an x in it?
Oh, okay, good question. So let's just say this is a different problem and this was just 2. It's a good question. Then what you would be doing is you'd be setting 2 equal to 0, wouldn't you? Like this is a factor, isn't it? So you'd be asking yourself, when does 2 equal 0? And basically that doesn't happen. So therefore, there's no answer from this. You'd only have 2 answers in that case. That make sense? Okay. Any other questions? Yes?
So is it 0 or is 0 one the answer?
Yes, it is. Yes.
Okay. So I just kind of do it differently.
All right, do you want to share? Because I don't mind. Can I just see it?
Yeah.
Here, I'll just come over there. Just want to make sure that it works. So what did you do here?
Well, I just kind of skip a lot of steps pretty much. Like I take
Okay,
this
that's
and
okay to do it that way.
Divide by the bottom and then just take that.
Yeah.
Change the sign.
Yep.
Make sure it's
So that's a different, last class I was talking about the AC method. This method right here, we teach the AC method with grouping, but there are shorter ways to do it. We just don't, as a math department, we don't teach those ways. Because what happened is we started to have like 8 different ways to do factoring, and we get students in college algebra, and they would all have different methods, right? So we were trying to be consistent, and this was the chosen one. But if you have a way, go for it. I just hope that that method was taught properly to you, because there are some problems where, like, that method does not work. It will fail if you forget to pull the GCF. If you forget the GCF, your answer's gonna be wrong. So there are some dangers with that, but it's fast, right? It's a lot quicker than the grouping. All right, well, y'all seem to be really happy right now, so how about we'll do one more? How about 2x squared minus 8x plus 1 equals 0? So do we have a GCF? Well, sorry, I should back up. This is nonlinear, right? It's already set to 0. So we just need to see if we can factor the left side. There's no GCF. There are 3 terms. So we're going to try AC. And our AC is, let's see, 2 here and negative 8 here. And so what did we say in this case? If we can't come up with 2 numbers that multiply to be 2 and add up to be negative 8, we said prime, right? That's what we said when we were factoring. But it actually turns out that there are 2 solutions here. There are 2 answers. It's just that our factoring is failing us. This actually does factor. It's just that we can't come up with the numbers. There are actually 2 numbers that do multiply to be 2 and add up to be negative 8. It's just you can't think of them because they're fractions. Am I making sense? So this method is great as long as we're working with integers, whole numbers, because our brains can process that. But these are some fractional things, and they could actually be things that aren't fractions, which we have a whole other name for, irrational numbers. But so if the problem was this on a test and I said factor, you would say prime, right? But because it says equals 0, you can't say prime and it be okay, right? We have to have a way of getting to this answer. So mathematicians, struggled with this for a long time, how to come up with the answers to this. And this